Hello class, welcome to the next segment in lecture 25, and in this segment we're going to be introducing some of the more mathematics behind air pollution, which is going to sort of be an extension of what we talked about in the previous segments. So with that, let's go ahead and dive right into it. So probably the most widely used metric or parameter, at least in the United States, is something known as the air quality index, which is basically a number that you plug in the concentrations of various atmospheric pollutants into an equation, and that equation gives you back a number, which gives you sort of an assessment of how much threat is to human life is posed by the air pollution levels. And this is sort of analogous to significant tornado index. Significant tornado index, you plug in a bunch of observed values, you get back a number that more or less represents what the potential risk for tornadoes might be in the atmosphere. Emphasis on might be, because it doesn't actually, high values of significant tornado index don't guarantee some sort of big tornado event, but air quality index works pretty much the same way. You plug in some observations into an equation, get a number back, and that number more or less represents how much of a threat is posed by atmospheric pollution in the that might be present. So that's sort of a qualitative overview of what air quality index represents. So again, this just takes in the concentrations of what are referred to as the 5 main pollutants in the atmosphere, and we'll actually go ahead and list those out. So one of the key ones is tropospheric ozone, and this is in contrast to stratospheric ozone. Ozone, that is three oxygen atoms bind together. Stratospheric ozone is great. In fact, we want stratospheric ozone because that limits the amount of ultraviolet radiation that is allowed to reach the ground. Tropospheric ozone is not great, and we'll actually take a look at some of the health effects of tropospheric ozone and why we don't want ozone in the troposphere. We want ozone in the stratosphere, but we don't want ozone in the troposphere. And all the pollutants that we list out here, we'll actually take a look at in greater detail and talk about how those pollutants actually negatively impact either the ecosystem and or the health of animal or plant life in the troposphere. Another main classification is particles or particulate matter, as another term for it, or more simply just known as aerosols, which are really fine particles of solid, really, really small solid particles. And again, we'll talk more about how exactly these negatively impact the health and why we care about them so much in some later segments. Another one, carbon monoxide, or just simply a carbon atom bound to an oxygen atom. Another one, sulfur dioxide, SO2, and then nitrogen oxides, which is kind of a broader category because you can actually have multiple different nitrogen oxide compounds, whether that's nitrogen oxide, nitrogen dioxide, or nitrogen trioxide, whatever it might be. Those kind of all have the same end effect when you look at the bigger picture. So that's kind of the reason why we give it such a broad category, even though there's multiple different molecules that might be causing the problems that nitrogen oxides cause. We refer to them very broadly as just nitrogen oxides. So those are the main 5 that the air quality index considers. So the concentrations of all 5 of these pollutants is accounted for in the air quality index calculation. And then another one that's also sort of a pollutant, but it's not included in the air quality index, which is why I have the little asterisk here. There's another class of molecules that we don't want in the atmosphere, but the effects are not necessarily a direct threat to life in the ecosystem. It's more of an indirect threat, and we'll talk more about this a little bit later on. But there's also a class of molecules called chlorofluorocarbons, or just simply CFCs, which is basically any molecule that has hydrogen, carbon, fluorine, and chlorine in it. Sometimes it doesn't have to include hydrogen, but just any molecule that has some sort of configuration of carbon, fluorine, and chlorine has a detrimental effect on the atmosphere, but it's not really an effect that is itself a direct threat. It's just what these molecules do in the stratosphere is what makes us care about them. But the reason why I put the asterisk here is because chlorofluorocarbons is not something that air quality index accounts for. Air quality index accounts for the first 5 that we listed. That is tropospheric ozone levels, how many aerosols are present, carbon monoxide, sulfur dioxide, nitrogen oxide. Chlorofluorocarbons isn't something that's considered to be part of the air quality index. So now you might be wondering what values of air quality index are actually meaningful. What number does the air quality index have to be for us to actually start becoming concerned? So that's what we're going to take a quick look at now. And you might have already seen or heard hints of this if you listen to any sort of air quality forecast. You might have heard level green, level yellow, whatever it might be, and that's actually that's actually something that's related to air quality index. And we'll go ahead and cover those right now. So an air quality index or AQI value between 0 and 50 is considered good air quality, and we represent that as a level green air quality. And basically, if the AQI value is between 0 and 50, then we don't expect any adverse health effects. So air quality is really good. It's definitely okay to step outside and breathe in that good air. AQI value 51 to 100, considered to be moderate air quality. The vast majority of people who step outside will be unaffected, but a few individuals might experience adverse health effects if they are especially sensitive to air pollution levels. And this is represented as a level yellow air quality. Values of 101 to 150, level orange. Usually at this threshold is when the National Weather Service the Texas Environment, or some sort of environmental agency. I use Texas because it's one I hear about a lot, but some sort of environmental agency, usually at this level, will issue an air quality alert, just saying there's air pollution levels could be a problem to those who are especially sensitive to atmospheric pollution. And this is referred to as the unhealthy for sensitive groups category. And again, that's a level orange air quality alert. And then an AQI value of 151 to 200, that's where you get into level red, and that's considered an unhealthy category. And that's when people who are normally sensitive, so people who would be impacted by level orange, they will be more significantly impacted to a level red. And this is also when people who aren't sensitive to air pollution might start experiencing adverse health effects right around this level. And then a value of 201 to 300, AQI of 201 to 300, that's when we go to level purple, and that's considered very unhealthy. And that's when you start becoming worried about the health of anyone who steps outside and starts to breathe in the air that's outside. Also, usually at this level, most localities will declare a public health emergency if you start seeing air quality index values that reach into level purple, just telling people to limit their exposure with the outside air as much as possible. And then finally, the highest value, which goes to an AQI that's over 300, that's considered level maroon, and that's considered to be the hazardous category. And basically, you just don't want to be breathing in the air that's outside. If you step outside for too long, then you might start having major health complications. Fortunately, in the United States, it's pretty rare to see anything above orange. On a handful of occasions, some metropolitan areas will get a level red if the atmosphere is especially conducive for high pollution levels, but usually you don't see anything above red unless there's some sort of industrial accident or wildfire nearby. Usually that's the only thing in the United States, at least, that will trigger an air pollution level higher than level red. But usually the worst that you get, at least in the U.S., is a level orange, and on a handful of occasions, maybe you get a level red, just from human activity itself. Usually doesn't get much higher than that, but like I said, if you have some sort of big wildfire or a big industrial accident, then you might have to start worrying about some higher level AQI values, some higher pollution levels. But that's going to do it for this segment on the air quality index. And in the next segment, we will talk a little bit more about some of the atmospheric conditions that we look for, which can signal the potential for high pollution levels. So with that, I will see you all in the next segment.